Hello, this is demo for the new additions to the MongoDB query capabilities in the 5.0 version. My name is Katya Kameneva. I'm a product manager here at MongoDB on a query team, and today I will guide you through it. These are the things that I would like to highlight. We added the detailed error message when the document fails validation. We implemented new expressions for working with nested fields and fields that contain dot or start with $sign. Also, there are new expressions for working with dates. There is a brand new feature of window functions for analytics, and some more. So let's get started. I'd like to start with the improvements to schema validation. By the way, here for the demo, I'm using the new Mongo SH shell, if you're wondering why it looks a little different from the old Mongo shell. So as an example, let's look at the database for marketplace application and collection of products. Let's see what is the validator for this collection. The validation rules are expressed using JSON schema. According to this, each document requires seller and product fields. Inside the seller subdocument, we also require name, and inside the product, the weight in grams should be integer with a minimum value of 1. Now, let's try to insert the document that doesn't match the rules. Here, seller name is missing and product weight is 0. We received an error message that indicates that the document failed validation and could not be inserted because of the missing property name inside of the seller, and also the comparison for the weight of grams failed. It is expected to see a minimum of 1 and it saw 0. The validation rules could also be expressed using MongoDB query language. For example, like this. We also require seller name and product fields and weight of the product to be greater than 1. Now, if we try to update an existing document and set weight to 0, we should get an error too. And here we see it, update failed because of the comparison operator greater or equal than 1 that was applied to the weight in grams field inside of the product. So I'm personally really excited about this improvement, as I know that many of you have struggled without this information, and now it will be so much easier to find the part of the document that didn't comply to the schema and identify a place in the code that produced the inconsistency. Now I'd like to show you the new additions to the language. First, the new aggregation expressions that make it easier to work with nested fields and fields with non-typical names. $get field and $set field. Let's say you're using change streams to track changes in our products collection to notice when items are at low stock. An event produced by the change stream can look like this. A nested field, stock, inside of the product is represented as product.stock. If we want to add some logic based on the value of the field, maybe produce some notification if stock goes beyond a certain threshold, we won't be able to use regular dotted path, because in MQL, dot is used for nested fields. A path like this will be interpreted as get the stock field from inside of the product subdocument, or get the stock field from the subdocument inside of the product array. But now you can use $get field to get the value from such a field. You will provide the literal name of the field, here it's product.stock, and a path to the object containing it. And this will return you the expected result. There is another use case for it. Let's look at the sample document from our collection again. Let's say we allow our seller users to create custom fields when describing our products, and then search by those fields. A user who created a field model year now wants to see the products from year 2019. This query will work just fine, but the model year is a variable part, and to construct this field path, you will probably need to concatenate the string. If you rewrite this query as an aggregation, you can treat the custom field as a variable when constructing your query. And $set field can be used in a similar fashion for updating the values of such fields. Next are the expressions for working with dates. $DateDiff lets you calculate the difference between dates. It accepts start and end date and a unit parameter to calculate the duration. Then you can add and subtract time frame to dates with $dateAdd and $dateSubtract. It is pretty straightforward. You pass your original date, unit, and amount. Here we added 8 hours to 5 o'clock and got 13 hours as a result. And then there is date truncation and binning, the new expression $dateTrunc that makes it easier to bucket dates and group by time intervals. For example, if we have a set of events with start date for each, and we want to compute some aggregate values, let's say within groups of 5 minutes, we can use dateTrunc. We provide the field that contains the date and describe the size of the bin. Here it is 5 minutes. And in the output, our documents will fall into those bins. Here, for 4 documents, we got 3 bins for 500, 505, and 510. In all these date expressions, unit can be anything from millisecond to a year, and you can also include specific time zone to take into account daylight savings, which can be important when calculating duration. Now, let's move on to the window functions. Window functions, sometimes also called analytic functions, perform calculations across a subset of entries related to the current entry. Let's say we have an ordered list of events, and we want to know the maximum value of some parameter over the 3 days. When we use aggregation function like group, we can filter to specific 3 days and calculate one number for this maximum value. With window functions, we can calculate max value over the last 3 days for each day. The output will not collapse documents into one group, but each document will now contain the calculated value based on the value from the adjacent document, or a window. In MongoDB, window can be position-based, like previous 10 records or next 10 records or all records preceding or following the current document, and also window can be time-based, and we can calculate, say, monthly moving average or year-to-date cumulative sum. Let me demo a few examples for how window function can be used. The queries here are a bit lengthy, so I will use MongoDB extension for VS Code. Let's look at the sample collection that I have here. Each time a user plays a game, we store identifier for the user, for the game, and the score, and the date into this collection. Now, let's say we want to show to specific user the rank among others for each game they played. First, we will use group to calculate the maximum score of each user for each game. So in the end, we will get one document per user per game and their score. Here I'm just moving the fields that we grouped by to the root of the document to flatten the structure. And now we are using new stage set window fields to calculate the rank of the user. We partition by game, sort by score descending, and use expression for rank calculation. There is no need to specify the window here because rank is calculated across entire set of the scores. Then we want to show for our user what are the players next to them on the leaderboard and what are their scores. Here we're specifying window -1 to 1, meaning from one document preceding to one document following the current one, still ordered by score. And we're just adding those documents into an array. Let's see what we get. So I got 3 users in the array. This is a current user number 6 with score of 25. The user number 7 is right behind him with a score 20, and user number 8 is in front of him with a score of 31. Notice I also added the filter for the current user in the end. It is important to keep that filter in the end because otherwise we could not perform all the previous calculation that considered scores of all the other users. Here is one more example. For each day when a user played a game, let's calculate the average daily high score over the last 3 days. Here we can filter for that one user in the beginning of the pipeline because we're not looking into other players' performance. Then we are using in the group our new expression $dateTrunc to group by date and get the highest daily score per game. Then there is window function to look at the last 3 days. Because we sort on date, we can express our range as a time interval. We will include current day and 2 preceding days. Our calculated field will be average over daily maximum score. Then again, I'm doing some restructuring to move all the fields to the root of the document and also round the calculated average. Let's run this. Let's look at the entry for June 7th. We looked 2 days back, but user didn't play on June 5th, so only score from June 7th and June 6th will participate in the calculation of the average. So I hope you're excited about the window functions. I think this is a great addition to the language as it enables so many new use cases. Now, I'd like to mention a few other small features, like the new let parameter that can be used to pass variables to your queries. It is supported for all the commands where you can use aggregation expressions like aggregate, find, update, delete, and find and modify. For example, if you have a common query like this, show all the sales of the specific product and calculate the difference of the sale price from some base price. You can parameterize the query values for the product name and base price and have them as variables. Then there is addition to the lookup syntax. If you use lookup, you probably know that if you want to add pipeline on the collection that you look up from, you will also have to have the expression for local and foreign fields in that pipeline. Now you don't need to do this. If you match local field and foreign field as an equality, you can keep them as simple definition here and only have more complex logic as part of the pipeline. And the last thing that I'd like to highlight is the extension of $if null. Now it can evaluate multiple expressions in order of significance. Let's say in my collection, field details contains the most important information about the product, and field description is less informative, but still useful. If I want to return only one of them in this order of importance, I can use $if null. Here I create new field info. And if the document contains details, I want the value of details to be used. If no details, then use description. And if none are available, then set some default, like no information available. As a result, for product A, field info contains details, and for product B, it contains description. I hope you found this useful. Of course, this is not the complete list of all the things that the query team shipped in this newest version of MongoDB. I encourage you to look at the release notes and try out some of the new features. And if you have any questions, feel free to post them on the developer community forum. We're always looking to hear your feedback, so please leave it on our feedback portal in the database section. Thank you!